Okay, welcome back, Algebra. I really think that you're going to enjoy this lesson today. We're going to build a lot on what we did early in the first semester. All right, so let's get going with this. Now, this first problem you already know how to do. 3x plus 7x. You see that those are like terms, the x's, so all we have to do is combine those like terms, and we have 3 of them, and we add 7 of them, and that's going to be 10 of them. This is just going to be 10x. Now, what about this next one? 3 root 3 plus 7 root 3. Well, let's think back just a second and go to the x's. 7x plus 3x. What does x equal in that problem, or what could it equal? It's a variable, so it could equal anything, right? That x could be 15 or 22. It could be -5, or that x could even be the square root of 3. Yeah, I know it sounds strange, but it can be any number, and the square root of 3 is certainly a number. So if we just think about these as x's, we see that they're the same, they're like terms. So 3 root 3 plus 7 root 3 is just going to be 10 root 3. Okay, you see that? The root 3's are like terms, so let's just combine them. Let's look at another problem that you know how to do. What happens if there's x's and y's? Well, combine your like terms. Just combine your x's. So we've got a 2x and a 5x. That's just going to be 7x. Then we've got a -4y and a -8y. -4 minus 8, that's going to be a -12y. And remember, we can't take this any further because the x's and y's aren't the same. So we have to be able to combine like terms, and those aren't like terms, so we're just done here. Let's look at the next problem. This next problem is going to be basically the exact same as the problem we just did just up above. You see, I have a root 7 and a root 7. Those are like terms. I can combine those. So 2 root 7 plus 5 root 7 is just going to be 7 root 7. And then my root 11s, those are like terms. I can combine those as well. -4 root 11 minus 8 root 11. That's going to be -12 root 11. And just like before, we can combine an x and a y. Down here, we can't combine a root 7 and a root 11. They're not like terms, so I can't add or subtract them. And we're just going to stop right there. Let's do a couple more problems like this. Again, like terms right here, root 13s. So what's 14 minus 5? I've got 14 of them. I take away 5 of them. That's going to be 9 of them. That's just 9 root 13. This next problem is interesting for a couple reasons. Number one is they're not all like terms, right? We've got root 5 and a root 5. So those two are going to go together, but we can't combine that with the root 7. Now, something else that's interesting is that last root 5 at the end. It doesn't have a number in front of it, but we know how to handle this. Remember what we did if we had a variable that did not have a number in front of it? If we just had an x, what was the number in front of it? That number was a 1, right? So let's just put a 1 in front of that root 5, and now let's combine it. 6 root 5 minus 1 root 5. 6 minus 1 is 5 of those root 5s. And then we have a -3 root 7. And I can't put those together. I can't add or subtract them if they're not alike. Let's look at this next one. Combine the root 17. Combine the root 7s first. 7 root 7 minus 5 root 7. 7 minus 5 is 2 root 7. And now the root 17s. 4 minus 3 is going to be 1, positive 1 root 17. So that's going to be our answer, but I bet you're saying, I think we can clean this up a little bit, and you're right. That 1 root 17, 1 times root 17 is just root 17. So we're done. We're finished with that. Let's move on. And let's look at this. Root 12 minus root 48. And you're probably thinking, well, those aren't like terms. We can just stop. This is already simplified. We can't add or subtract those because they're not the same. If you thought that, high five, you're tracking exactly what I'm saying, but you did forget one thing. Remember last lesson we worked on simplifying square roots? Let's simplify this root 12 and see what happens. If we find the factors of 12, and remember the first one has to be a perfect square. So looking down here, what can I divide 12 by? I can divide it by 4. So root 12 is the same thing as root 4 times root 3. And the square root of 12, we might as well just rewrite that as 2. Square root of 4 is 2. I'm sorry, square root of 4. How about root 48? Well, the biggest perfect square that I can divide 48 by is 16. So this is just going to be root 16 times root 3. And the square root of 16, we know, square root of 16 is just 4. So look at this. Those are like terms after all. They were just hidden. So 2 root 12, root 12 is 2 root 3. Root 48 is 4 root 3. So now they're like terms. 2 minus 4 is going to be negative 2 root 3. Let's do 2 more like that. Okay, so root 18, that's root 9 times root 2. Root 50, that's going to be root 25 times root 2. And root 32, that's root 16 times root 2. Now let's simplify these. Root 9 is just going to be 3 root 2. Root 25 is 5 root 2. And root 16 is just going to be 4 root 2. All right, so now let's combine these. They're all the same. So we've got a 3 minus 5 is negative 2, plus 4 is going to be positive 2. So this is going to be positive 2 root 2. All right, last problem, and this one's tricky. All right, so 2 root 50, so that 2 is going to stay there. Root 50 is what times what? Root 25 times root 2. That's what root 50 is. So we've got the 2, and root 50 is root 25 times root 2. So this is just 2 times, root 25 is 5 root 2. Let's simplify that. What's 2 times 5? This is just going to be 10 root 2. Now, did you catch that? There was a lot of steps in there. I moved quick. If you didn't catch that, if you don't see exactly how I got 10 root 2, go back, pause the video, rewind this, and watch that part again, okay? But make sure you saw that, because that 2 up front makes it tricky. How about this 3 root 8? Well, that's 3 times root 8. Root 8, that's going to be root 4 times root 2. And root 4 is just 2 root 2. And 3 times 2, normal 3 times normal 2 is 6 root 2. Okay, did you catch that one? Make sure you caught that one. From this point now, it's easy. I've got 10 of the root 2's plus 6 of the root 2's. That's just going to be 16 root 2. Okay, this was not an easy lesson. I know that. It's confusing, especially that last problem. If you need to see it, make sure you watch it again or ask me in class, all right? I know you can do this. Good luck.